Welcome. Welcome to the second session of Research Methods in the Patel College of Global Sustainability. As you know, I'm Dr. Joseph Dorsey. I'm an adjunct professor. And we started this series because we wanted to make sure that with the internships that you're going to be conducting, that you have a good background in research methodology, both quantitative and qualitative. Last time we met, I talked about qualitative research methods. Today, I'm going to focus on quantitative methodology in research design, process of acquiring knowledge. Today's agenda will cover quantitative research, a scientific process of research, qualitative research, a quick review. So I'm going to go back and talk about qualitative for a little bit. Combining qualitative and quantitative methods in evaluative research, and significance of community and university interaction. So quantitative research, it asks why something is the way it is, or it might ask how much, or what will happen if I do this? It usually entails many cases and a few variables, and I'll get more into the details of that later. It's about numbers, using statistics and measurement. It's representative of a sample, of a population rather, and we use the sampling to do that. And it also normally looks at relationships and associations or causality between variables. And we also test hypothesis. So if you have some sort of hypothesis of what you expect out of something quantitative rather, test that. The scientific process of research. So we're going to have some basic assumptions about science and scientific research. Science is built upon assumptions, and here's a definition of what assumption is. It's ideas that are tentatively accepted as being true without further examination. But science makes fewer assumptions, preferring to subject most ideas to rational and empirical challenges. So we all have assumptions, but science tries to test those assumptions. So in order to do that, what you need to do is pose a question. Now, with any type of research, it comes with a question. That's pretty much what life is about, questioning the things that happen around us. And so you pose a question, and then you develop procedures to answer that question. You plan for and make appropriate empirical observations, rationally interpret empirical observations, and use those interpretations to predict other events. So really, research is an ongoing process. It doesn't necessarily stop with the first thing that you do. You're constantly getting more information, and from that information, you may move forward to do more research. So right now, I'm going to touch on the concept of facts and constructs. Now, facts are those events that we can observe directly and repeatedly. So if something is, you notice that this structure here is always here, we call it a table. So it's a fact that if you see it here in the classroom and it has legs and it has a smooth surface, this is a table. So you can say maybe that's a fact. Okay? Constructs are rational ideas constructed by the research to explain observable events. So if you look at constructs, it's constructing. It's like when you say, if I want to explain something, you have to use several ways of talking about it, and each way that you talk about it is a construct. You're constructing an argument. You're constructing something that others can observe. And it's pretty much giving it a name. Observation and inference. So observation is something we do all the time, every day. In the context of research, it's an empirical process using one's senses to recognize and record facts. So you have to, trust your judgments, that when you're doing research and your observation, you're seeing what you want to see, and then you have to figure out how to record what you're observing. Inference is an intellectual process in which we derive conclusions from observed facts and ideas. So once you've looked at facts and created constructs and did observation, now you can get closer to saying that you think you know what you're looking at. And that's what we call an inference. But you can't just have an inference unless you spend some time gathering a certain amount of information to give you that inference. Now, there's also part of what research has to do with different types of thinking, and there are two basic types. There's the inductive reasoning, and that's reasoning going from the particular to the general. A researcher who begins with empirical observation, then infers constructs, is engaged in inductive reasoning. But I like to use maybe another example to make it a little more simple. For example, if you say something has a bushy tail and it eats nuts and it goes up into trees and it chirps, and well, they maybe don't chirp that much, don't hear them too often, but sometimes you'll hear them. Well, what do you think I'm talking about? Okay, so I took certain clues, certain pieces of what that creature is, and then once I told you those, that was enough information to say, oh, that's a squirrel. So you took the specific and went to the general. Now, if I took a picture, now, so let's go to deductive reasoning, which is abstract, taking abstract or general ideas to specific, taking the large to the specific. And within that, you're using constructs as the basis for making predictions about new specific observation. And this is deductive reasoning. So let's get away from this sort of technical stuff to back to the squirrel. If I show you a picture of a squirrel, you're going to assume that there's certain things that squirrel does, that it eats nuts and it runs around and climbs trees and has a tail. So this is the difference. Now I'm showing you a picture, and now you've taken the general, and now you can pull out specifics from that one picture. And so that's kind of the difference between the inductive, taking pieces and creating something out of that, or the others having a general observation, and then you can find pieces out of that. And those are two different ways of reasoning that takes place in research. Other aspects of research are things called theories and models. A theory is a formalized set of concepts that summarizes and organizes observations and inferences, provides tentative explanation of phenomena, and provides the basis for making predictions. So it takes a lot of what we've already talked about, and once you have enough of that information, you can form a theory around that. Theories are the glue that holds science together and the framework that enables researchers to build on the work of others. So when theories are there, you can build upon a theory because someone else has done the work to create the theory, and you know the pieces of that theory. And so if you can create new theories based upon old theories. So theories are constantly built upon. And theories don't necessarily mean that something's true. It's just that you have enough information and observation to come to some conclusions. And that's why you use hypotheses to test those theories. And sometimes the hypothesis may come up not supporting the theory. And so one thing I learned when I took research methods and stuff when I was in school before is that you can't, with a hypothesis, you can't prove a hypothesis. A lot of people say, I want to prove a hypothesis. You can't prove it. You can only support it or reject it. And that's a very important component of the idea of a hypothesis, because we really don't know, ultimately we don't really know what's true, and so we always come close. That's why when you're looking at research, they tend to come to this like 99.9%, probability accuracy. You can never get 100% because there's always a margin of error because we're imperfect. And so our measurements are imperfect as well. We can come very close, but we can never get 100%. So when you're looking at a hypothesis, it's something that you can support it or reject it, but you can't really prove, that your hypothesis is right. Modeling, it's derived from the word modulus, meaning a small measure of something. A model is a description of, or analogy, that helps scientists to understand something usually unseen and complex. So models represent reality, but they do not duplicate it. So models, they're symbolic, they visually represent something, but a model is just a model. It's never the actual thing itself. But in research, we use models often to help people visually see things that maybe don't exist yet, and so or something that exists, but you want to replicate it for some reason. So there's several phases of research. And this is something that you'll be going through anyway with your internship. Maybe it's said differently in the guidelines, but all phases of research pretty much go through this. One is the idea generating. So you have an idea and you want to do something with it. You identify a topic that you want to study, and then you define the problem. Now, you may have some vague, ideas, but you know that there's a problem that you want to address. As I said in the last lecture that I did, that reason that we're all here is that we want to solve problems. You may want to get information and education, but ultimately that has to be applied to some problem solving, and research is about that as well. There's no point.
Is there always a problem, or we can make up not a problem, but say it could be more efficient if?
Yeah, problem. When I say problem, it doesn't have to be a major catastrophe problem. It could be just something that needs some observation. But I think life is always solving something. Problems can be large or small. And just even adjusting your seat. You feel uncomfortable in your seat, and you adjust your seat so you feel more comfortable. You had a problem of being uncomfortable, and you did something about it. So it's almost, I think, life in general is problems, and when you look at the magnitude of problems, that's where research comes in, because we generally want to know something. And just wanting to know itself is somewhat of a problem. You get what I'm saying? I know it sounds a little abstract, but yeah, okay. So there are procedures in design. So with that, now that you've generated an idea, you've kind of defined what the problem is, now you have to design some way of dealing with it. So decide on specific procedures for gathering and analyzing data. And it's very important, if you go in the route of quantitative research, that you know how you're going to analyze your data. Because if you just think about gathering and you don't know what you're going to do with it, it's kind of like you have to figure out when you get it what you're going to do with it. You don't want to just go down a blind path and then you get this data and you're standing there going, now I got this stuff, what do I do? So in a way, when you design your study, you have to design the whole study. You have to know what you're starting off with and how you're going to end. Once again, observations are there. You collect your observations. And observations, a lot of, they talk about, you think about it as looking something with your eyes, but I think you can almost interpret it as well as maybe instruments, surveys and things like that. There are observations there too. You're getting information, and so don't think of observations as just visually looking at something happen, but also getting information that you can look at it. So I think if you look at observation, you can take a more generalized understanding what that means. And data analysis, of course, using appropriate statistical measures. And we come back to this concept of interpretation. So you have to interpret what you have. Like, it's almost like when I talked earlier about us having incomplete knowledge, never quite knowing. And so even when you get data, you really kind of have to figure out, well, what am I looking at? And that takes some time to figure out what you're really looking at. And then once you come to some conclusion that you found something that you think people should know about, then you prepare a report or some written or oral report that can go into a publication or a presentation. But communication is really important. That's how we build on other people's work. So there's several levels of constraint in research, scientific research. Now, I think I have to explain the word constraint. The way it's said here is that when you're doing research, you can only do but so much with any type of methodology. And there's a reason why there's certain constraints. Now, the lightest constraint would say be the naturalistic observation, or low constraint. When you're observing participants in a natural environment, say you're watching people play in a field, or you're watching animals doing something in the woods or something, and you're just observing, there's not much going on. You're not constrained. It's very low. You're not controlling much of what's going on. So observation is a very low constraint. The next maybe higher constraint would be a case study research, where you're putting the participant in a moderately limited environment, slightly intervention, and observe response. Now, even though this terminology is that you're doing something with the person, it may be just as simple as asking someone to sit in a room and fill out a questionnaire for you, and you're looking at them as a case study. So there's some limiting of the environment, meaning that instead of them running through the field doing the survey, they've got to sit down, and so you've limited part of that naturalistic observation. And then there's correlational research, which is quantifying the strength of relationship between two variables. So now when you're looking at two things or something like that, there's a little more control here. You're not just looking at, say, a case of one person or one event, but now you're looking at several things. So now you're kind of increasing your constraint. A differential research compares two or more pre-existing groups of participants. So we've gone from just looking at things to actually comparing groups of people, which means there's attitudes and there's information that is going to cause a lot more engagement in the process. And then, of course, the experimental research, where you assist participants randomly, assign participants randomly to groups, then test each group under a different condition. Now you're thinking about maybe people in a laboratory and you've set up the conditions and it's very controlled. So this would be a high level of constraint because there's a lot of conditions that you brought into the process. So like I said before, research is about questions, asking and refining questions. There's two ways we can look at this process of questioning. One is the heuristic influence, and this is where theories and research findings generate interest. And so it could be things such as disbelief or outright antagonism, but it suggests further research questions. So what it's basically saying here, these are questions that come from what's being told, what's being seen, what's observed, and it creates more questions. It generates more things that you want to know. The systematic influence is theories of research to provide testable propositions for future research. So right here we're talking about, I guess the operative word is testable, where you can perform tests. With the heuristic, you don't necessarily have tests there. You're doing observations, you're gathering data, but you're not trying to replicate something. So this is two ways of, I guess, focusing on questions. Research begins with questions that gradually refine until they become specific enough to give research a clear direction for answering them. So it's kind of saying here that questions start off kind of broad in general, and then eventually you can get them much more specific to what you're trying to find out. Developing the initial question is critical because it determines how we will conduct the research. So you have to make sure you're asking the right question. You don't want to spend time going down a pathway and then you realize, maybe this wasn't what I wanted to know, or this is not the kind of question that's going to get me where I want to be. So even though a question sounds like a simple thing, it's really a big deal in research because that question, you build all your research on the questions that you want to ask. The more that is known about a particular area, the more refined the questions will be, and the more likely high constraint research methods will be used. And this is basically saying that when you're a specialist in your field, you tend to ask more specific, poignant questions because you know enough about what you want to know to ask very, concise. You're very concise in what you're asking. If you're in an area where you don't know very much about what you want to know or what you're looking at, the initial question may be sort of undefined, less specific. And so this is more like when we talk about when you're kind of clutching or you're fishing. You're just trying to get some information, but you're not quite sure what you want. And so there are two ways of looking at questions. Now, research variables are any set of events that may have different values. So a variable is, pretty much anything that can change over time based upon whatever it is. And so I know it's kind of general, but I'll explain here. There's several types of variables. One is a behavioral variable, which is the observable response of an organism. So like I said, let's go back to our squirrel again. You know, if you want to watch the squirrel, what they do, you're basically looking at its behavior. You know, you're watching how it eats, or, you know, what it does, what it grooms itself, what it runs away or whatever. So that behavioral is whatever variables are there are based upon the behavior of the organism. Stimulus is the environmental factors that affect the organism's response. So if you were just observing the behavior, that's fine. But if you started to move towards the squirrel, then you might see that squirrel dart up a tree. So you've created now a stimulus. And you can do that in other, you know, when you're looking at other aspects of research, if you introduce something that's going to cause some kind of reaction, then that's a stimulus variable, which creates some kind of response in the organism. Organismic characteristics used to clarify the organism for research purpose. So it's classifying, sorry. What is it? So now you could say, well, a squirrel has these variables, but if we put a monkey there, you could say, well, you know, monkeys climb trees, monkeys have tails, monkeys eat nuts. So you get the sense that just because you say certain characteristics that normally apply to a squirrel, they may apply to a monkey as well. So you have to now say, well, we're talking about monkeys, we're not talking about squirrels. So you got to start now classifying the organism, and so make sure people don't get mixed up. Independent variables are those variables that you can manipulate yourself, that you can change the variable. You could say if you were doing a study on maybe coffee and tea, you know, you give one group coffee and you get one group tea. There's still drinks, but you just want to find out how to react to two different types of drinks. So that independent variable is something that you manipulate. The dependent variable is affected by the independent manipulation. So the dependent variable might be the person has a preference for one drink or the other. And so now you're introducing some manipulation, but the dependent is the individual. They don't change other than what their opinion changes and so forth. But that's where you're using manipulation on that dependent variable. And of course, there's what they call the extraneous, which is the sort of any variable other than the independent variable affecting the dependent measure of the study. So it could be, now if I'm thinking about this example, if you didn't tell the person to not drink anything before they came to the research, they may have drank so much of something else that now that they're at the research, they can't drink as much of the tea or the coffee that you wanted them to drink. So that was sort of the extraneous variable, something that you didn't really put into it and didn't control, but just happens to be there. Now, a constant is any event that is prevented from varying. And I don't know, I mean, you know, any example, it's constant just something that's always doesn't change. So if you always did your research in the same building all the time for 20, 30 years, research is always there, then maybe you could say that's a constant. You know, unless you change buildings where you do the research, the constant may be it's the same building that we always do the research in. So I think this kind of helps to explain a little bit about what research variables are. There are also scales of measurement, and you probably are familiar with these. One is the nominal. Naming scales, the only property is identity. So nominal is when you say, well, what's your political affiliation? You say, well, I'm a Republican, I'm a Democrat, or you know that you're a Christian, or you're Jewish or Muslim, and that's it. That's the nominal measurement. It just labels. It identifies you as something. You're a mother, you're a father, sister, brother, whatever. It's nominal. Ordinal measures a variable in order of magnitude. So there's a ranking system here. I'm the professor. You guys are students, so there's some sort of ordinal aspect to that. It's just a measure of order. Some things are larger than other things, you know, just proportions and so forth. Now the interval scale of measurement is where we have equal intervals between consecutive values of a scale. For example, a thermometer. We're all familiar with a thermometer where, you know, between temperatures there's numbers and lines between various temperatures, and it's evenly spread out. Test scores. I know you guys thinking about taking a test today. You know, there's probably it's out of 100 points or 200. I don't know how many points this exam will be, but everyone understands the ordinal scale, the A, B, C, D, F, as we do with grading. This is intervals. You know, there's a certain distance that should be equal. There should be equal number between an A grade and a B grade and so forth. So that's kind of the interval stuff. The ratio takes in consideration all of these properties, and it also has the true value of the 0 point. Where these others don't have a 0 point, you can have 0 point in the ratio. So we talk about things like weight and length and reaction time and number of responses in research. A lot of times it's the ratio that you're looking at. Now I mentioned before about error. So when you're looking at research, measurement error is anything that distorts the scores so that the observations do not accurately reflect reality. Yeah, I was reading, as I was reading a book to sort of prep for this, a measurement error could be, say you want to weigh somebody, but they decide that they're going to like lean against the wall while they're being weighed. Well, is that going to give you the true weight of that person? You know, some of that weight will be taken away or even added, I don't know, by leaning against the wall. And so you can look at, anytime you're doing research, there's going to be maybe some error in measurement because there are things that you may not be able to see or control that's taking place that creates some error in the measurement. Response set bias is a tendency to respond in a specific ways regardless of the situation or experiences. So that could be a person who's really stubborn about something, and you could give them all the information about why they're wrong, and they just still going to continue to believe or do what they want to do. And so there's a bias that's there that doesn't change for whatever reason. A little similar to that is the notion of social desirability, which is a tendency to respond in a socially acceptable manner. That's when the respondent will tell you what they think you want them to tell you. Yeah, so if they know that you're gonna, if they think that you want to hear a certain type of answer, because if they answer differently, they would look like a bad person. They're going to tell you only the good stuff. And that's another bias and measurement error, that just because you ask a person a question in research doesn't mean that they're actually giving you the answer. There could be a little lie going on there for whatever reason. They don't want to be embarrassed. They don't want you to think badly of them or whatever. And so these can create measurement errors. So anytime you see polling and any type of study, that's why there's sort of these points, plus or negative, because there may be some error that's in that, and they give space for error. Operational definitions. Now, an operational definition, as it says here, is a definition of a variable in terms of procedures used to measure or manipulate. Well, let me just put it in more simple terms. If you're going to talk about anything, you have to define what it is. So when people are reading it, they can understand what you're talking about. So an operational definition is not just a definition, but it's a definition that helps the reader understand what you're trying to get to, where this is going. So it's like operationalizing. Let me think of an example of maybe an operationalized definition. Well, let's do something really easy to understand, a university. So if someone says, well, I'm at a university because universities educate, they provide services to communities, they help uplift people and get them jobs. So that's what a university is. So anytime someone says, well, what are you studying? Well, I'm studying in university. And they might ask why. Well, let me know why. You've given me an operational definition. Because it does this, it does that. So definition, that helps you doing your research to be able to explain why you're doing something. People won't have to ask the question because the definition itself justifies why you're doing. So an operational definition brings theoretical abstractions to an empirical level and describes exactly how to measure the theoretical abstraction. So, it's a little different than what my sort of analogy, but it's helping you to be able to explain the measurement, why you're doing, because a lot of these, like it says here, a lot of these are abstract concepts and you have to sort of bring it down to a practical level. And operationally defining things makes it more practical. Now, evaluating these measures, there's the notion of reliability. Now, this is a big concept in research in general, but particularly in quantitative research, is the notion of something being reliable. Meaning that if you ask someone else to do it with the same information or same tools or measurements, they should be able to get the same thing that you got. Research would mean nothing if it wasn't reliable, meaning that you couldn't trust it. And so with the inter-rater reliability, at least two independent observers rate the same thing. So this is an example of, say, if you had, this is an example. Recently, when students were talking about the papers, because I'm teaching this course with another professor, and there's a paper assignment that he assigned, and then I'm doing one, and we're grading them independently. Now, what would be the inter-rater reliability would be if we both looked at the same paper and read it over and then gave a mutual grade. You see what I'm saying? I read it, he reads it, and then we both decide on what grade that one paper gets. Then you have two independent observers rating the same thing, okay? So that would be reliable because you could say that between the two people, they would come to some middle ground about what this grade should be. If they did it independently, one might say, oh, this is an A paper. The other might say, well, this is a C paper. If they don't, but when they read it together, they may come up and say, well, this is actually a B paper. And that gives you a more accurate understanding of what that paper maybe is. Now, a test and retest reliability is variables that remain stable over time and should produce similar scores if we test participants at two different times. And so, you may give people, and we did that starting orientation week by giving a pretest about what people know. And then if we give you a test later on, same test, we can kind of see where you changed your scores or not. Now that's one way of doing the test retest, but I guess the way it's mentioned here is that you could give the person the same test twice and just see what the scores are. Now maybe the person will take the test the first time and they get an 80 on it. And then you give them the same test second time and they get a 90. So you can almost say, well, the average score is 85. That person is sort of that's where you get this test retest, and that shows you, if the person, okay, let's think of it another way. If I gave the test to that person the third time the same test, well, you would assume they would get a better grade, hopefully, because they've seen the answers before, unless you don't tell them whether they were right or wrong. And maybe if you never tell them, this is if the answers are right or wrong, and you just keep giving them the same test, that person will probably get an 85 the third time they take the test. So now you're starting to see that no matter what you do, they're going to stay within that same range. And I think that's what the test-retest reliability is showing, that anytime you ask that person to test, they'll probably get around the same grade. Okay, now internal consistency reliability, several observations are made to obtain a score for each participant. So internal consistency is testing the test itself. Now, where the first one, well, second rather, the test-retest, you're testing the individual to see whether they're going to be doing the same thing or not. With the internal reliability, you want to see if the test, if if people take that test, different people take it, will they all somehow get around the same score? So you're kind of showing that the test itself is fair, that there's nothing crazy about the test where one person's taking it and they're getting a 20 and the other person's getting a 90, if they're equally prepared. You kind of want to see what I'm saying. If everyone's equally prepared, then they all should be getting around the same thing on the test. And that's testing the test itself to make sure that test has internal consistency. It's a reliable test. So you could take that same test and take it to another school where students are equally prepared. They should all be getting around the same type of grade. So you're testing the test at this point. And this is how we look at making sure that things are reliable. Another concept is the effective range, appropriate and significant scaling. And the best way to mention that is, one of the examples in the book I was using was weight. If you wanted to measure the weight of a mouse and you wanted to measure the weight of an elephant, would you use the same scales? No, because any scale that you would put a mouse on to get its weight would be, the elephant would pretty much crush that scale, right? Or if you have a scale that measures tons and you drop a mouse on it, you probably wouldn't even see the scale move at all. And so what this is saying that you have to have the appropriate scaling and arranging when you're measuring something. So anytime you're measuring something, you're making sure that it's appropriate and the scaling is sufficient for what you're trying to measure. Because if you're trying to measure, like I said, something extremely large with a measurement tool that's too small, you're not going to get what you're looking for, and vice versa. Another major concept for evaluating is validity. This is sort of the sister concept with reliability. The scale measures what it's supposed to measure. So validity within that is that, are you really getting what you're looking for? If it's not telling you what you're looking for, then it's not valid, and so why would you use it? So you have to make sure that the scaling is giving you what you're looking for, and of course doing different things to test it. And I think reliability kind of goes hand in hand with validity. When something's reliable, it sort of helps it become more valid, and vice versa. Now, objective measurement, measurements that give the same result no matter who's doing the measure. So that's the important thing about quantitative research, is that it's objective, that it's not biased. Anyone could get the same results. If you give them the same format, the same proposal, and say, here's the proposal I did, and they take it and they go line by line, and they do exactly everything that you said that they need to do, they should be able to get the same results that you got, because it's objective, and that's an important principle. Now, I talked about this in the last session about ethics, and I'm going to talk about it again because this is an important cornerstone of research, right? Ethical principles of human research. And it has two great obligations for research. One is we're looking out for the well-being of the participants, and we're seeking truth. So once again, when you're doing research, you have to avoid deception. And the definition of deception is deliberately misleading the participants. You don't want to deliberately mislead people in research. It could be something that's not good for them. It could ruin your reputation. And so I guess there's a little, sometimes you don't want to really tell people what you're doing. You want to get information, and you say, if I give too much information, then they may not want to do it. But in research, you really have to be pretty much honest about what you're doing and give people an opportunity to decide for themselves whether they want to be a part of it. Because you can have invasions of privacy when researchers are examining very sensitive issues. And people will have recourse to sue. They can decide that this wasn't done fairly and may want to sue the university or sue you and so forth. And so remember, you're dealing with the public. You're asking people to assist you, and so you don't want to mess up that trust. A lot of times you have to maintain strict confidentiality of information, because a lot of times people say, well, they'll participate, but they don't want necessarily people to know who they are. That's why in quantitative research, it's you see mostly only numbers. You don't really know who the people are. A certain percent of people said this or whatever, and so it's aggregated into a pot of numbers and information, and so the confidentiality of individuals is not at risk. And like we said before, it should be voluntary. Nobody wants to be forced to do anything. You wouldn't want somebody to walk up to you and grab you by the arm and throw you in a chair and say, sit down and take this questionnaire. You'd be like, are you kidding? What's wrong with you? You crazy? Well, that's the point. People who participate in research to a certain degree should have informed consent. That's why you very rarely, you never really should ethically see children being interviewed unless the consent of the parents. You just can't ask a child questions for an interview because that's ethically, because they're considered minors. And so informed consent is very important, meaning that it's not just that you ask a person. Generally, you have to fill out, you have to a form that they read, and then you ask, do they understand everything, and then they actually sign off. Because this is a way of protecting yourself in the future, because the person they may change their mind at some point and say, well, I don't want to be part of the study, but you already did it, and you find informed consent. So there's nothing you can do. But if you don't have that informed consent and someone decides they want to take action, then you can get in trouble. So you can either provide enough information on research for them to make reasonable, informed decisions for participation. So the key to the matter of this is that you want people to give you their true feelings. And so if you come kind of at them shady and with misdeception, then you may get deception back. And so this whole process is supposed to be one where everybody's above board, everyone's honest, and there's a certain amount of trust there. So with ethical principles of human research, what we have on this campus, as well as mostly all campuses across the nation, are institutional review boards, or what they call the IRB. And the IRBs consist of researchers, peers, and members of the community at large. Universities, research institutions, hospitals, and schools systems establish IRBs to review research proposals to see if they meet ethical guidelines. So this is sort of the key here. They're there to review the research proposals at an institution, whether it's faculty or even graduate students or even undergraduate students. Anytime you're going to be dealing with what we call human subjects, you're going to be asking people questions. Now, if you're asking questions that are not going to really be sensitive, you may not necessarily need to go through the IRB approval. But if you're asking questions where you're taking people's their demographic information, whether they're male, female, their age, all of this information that's very personal and sensitive, and then you start asking them questions about their lives, about how they feel about things, you're starting to get into, you can probe into their lives. So the institution doesn't want to get in trouble for people being upset because they're asked questions that they think are offensive, may put them in jeopardy, may risk their lives in some way, may make them, reveal things about them that they don't want the world to know. And so you have to be very careful, and that's what universities do. So you as the researcher, though, is responsible for submitting your research proposals to the IRB for review and approval before you gather your data. Now, if you're not dealing with human subjects at all, you don't have to worry about any of this stuff. And we don't deal with animals here, so we don't have to, there's a whole thing for animals as well. But if you do decide you want to spend some time asking people a series of questions, you really need to at least show us first, and we can determine whether these questions are so sensitive you need to go to IRB, and then you would go to apply. And I think it takes several weeks, maybe, can be up to maybe 6 weeks, where they will review your questionnaire and decide whether they want to approve it or not, or maybe you should change some things or take out some questions or whatever. But it's basically to protect three entities: protect the university, of course, to protect you, and then protect the people that you interview, so that nobody gets in trouble. So research is judged on its value to science, And also, this is what's really important, the risk it posed to the participants. Really, all this stuff comes down to risk to the participants, you know. And I've gone through IRB approval several times. I've, you know, had taken the test. And one of the things that, if you think about experiments that were done by, say, Nazis during the Second World War, these were things that they did on people that there was no control, no review of what they did. And then even one more close to the, here in the United States was the Tuskegee study, where I can't remember whether it was back in the 40s or so, where there were some black farmers in Alabama who had syphilis. And I think there was a study where they were telling them they were giving them treatments. But what they were doing was just studying the progress of syphilis in the community. And that was a study that sort of started this IRB thing, because people were realizing that there was a lot of research that was taking place without any oversight that was actually harming people. So nationally, they agreed upon that any type of research that deals with human subjects has to be observed by a larger body within an institution, whether it's a hospital or school or university. So it deals with the risk posed to the participants. Also, whether there's, but is there potential benefits that outweigh the risks? So if it is about drugs, you know, there may be some risks there, but if the benefits are better, that the drug shows that it really works well, then that's a reason to take those risks. And also, they want to make sure that there's safeguards that are put there to minimize risk, that you actually are doing things to guard people's, you know, their privacy, that you're not trying to talk to children without the parents knowing about it, different things like that. Where are the safeguards? And, you know, if they're there, then you should get approval. And like I said before, it's really serious and it's really a big deal, but the research we've done here so far, I don't think many people have had to go through IRB approval for their research, but I think, you know, the more I educate you about research and the more some of you decide you want to do maybe more serious research, particularly those who maybe want to do two-year program, because I think because we have a one-year program, a lot of what I'm talking about is just too much to do in a year. But if you do decide you're maybe going to do a two-year program, then maybe this is something you can think about so that your thesis at the end, well, your proposal actually becomes a thesis, you know, and you have more time to work on these things. So a big part of this is sampling. And our sampling determines which participants to observe or test. And the reason is because you can't interview everybody. You know, you couldn't interview everybody at the university or, you know, or in the city, or you may want to know something. That's why when you see polling, political polling, they ask several hundred people or several thousand people questions, in a city. Obviously, the most accurate thing to do would be ask every single voter in the whole city what they think, but that's impossible to do. So what we do in research is we sample, we get a representative sample. And representativeness refers to how close a sample represents the population under study. So you get people across the spectrum that represent the community, you know, and in the right proportions, and you're assuming that if you were to multiply it across the city, you would get the same results. And so that's what sampling is getting a representative group. The more representative the sample, the more confidence in the generalizability of findings. So the operative word is generalizing, that you can generalize and say, yeah, based upon this sample, we're assuming that this is what the larger population is thinking or what they would say. But when a sample differs from the general population, and sometimes you may get a sample that's not like the general population, you must take care in generalizing research findings. So, I mean, you know, that's a no-brainer. You know, you don't always get a sample. Well, for example, if you were just interviewing people in just a certain neighborhood, you could not say that that represents the whole city, you know. That's why we do random sampling normally, so that you get enough people that you're not selecting necessarily who you want. You want a certain number, you maybe want 1,000 people, but you're not focusing on just 1,000 in one neighborhood, you're focusing on 1,000 across the whole city, and hopefully you will touch on enough diversity that you can say this is representative of the city. So surveys, experiments, and other collection methods. Surveys allow us to collect samples from a large number of people and compare and combine them in meaningful ways. I think all of us have taken surveys. I don't think there's anybody who hasn't. I mean, people are constantly asking, take surveys online, or sometimes you may be walking through a mall or something and somebody come up and say, can you take a survey, or whatever. It's just a way of getting a sample of what people, what they think will represent a certain group of people. Now, a longitudinal survey design involves a survey of a group of people over several times over, which means over a long time. Even the word there, longitudinal, means over a long time. So that's if you followed, a good example would be if you wanted to follow people to see if they got to go to college. So you may start off with this school, and you start off in kindergarten or first grade or whatever, and you follow these same kids through elementary school, into middle school, into high school, and see how many actually graduate and go to college. That's a longitudinal study. You're following the same population for a certain period of time, and you could get some really rich data. Of course, it's time consuming, it costs a lot of money, but that's what a longitudinal study would do. Experimental design entails participants being randomly selected to groups and all appropriate controls procedures used. So this is, when you say experiments, you're controlling a lot of the factors. Just think of, the lab, the mad scientists in the lab with all the bubbling stuff and, doing something. It's not quite that crazy looking, but experiments tend to take controlling, putting people in a booth, or, they have to stay in a room for a certain amount of time, or there's only certain people can interact with only other types of people. So there's a lot of control taken there. But you really want to make sure that it's random, meaning that you're selecting just across a spectrum without really specializing. Because when you randomly select, in theory, you get a representative of a population rather than just specifically going at one specific group. Of course, non-experimental design, as any research design, does not include the manipulation of independent variables or having a control group. That's different from your experiment group where one gets something and the other doesn't. People have heard of placebo. When you try out a drug sometime, you'll have one group that really gets the drug and another group that will get something that looks like the drug, but it's not the same thing, and see if they react, and if it's physically or whether psychologically people are reacting. And so these are, oh, sorry, I already got those. Yeah, did you? All right, move on. Okay, so this is probably the big question. Statistical analysis of data. Sorry, that's beyond the scope of this presentation, That's like a whole nother thing. I mean, this was a statistics class. You'd have to take that. I'm just covering sort of the method stuff, but statistics is a whole nother animal. So, but once you get this information down, you want to go further, and you can find a statistics book, and it kind of take you to the next level. But so let's kind of compare you got the we're going to do a qualitative research and a quick review. So qualitative inquiry, it's going from an exploration to discovery, and this is a pretty simple. This is probably the most simple way of thinking about it. Qualitative is we're exploring to find something. You want to discover something. Detailed view or observation. This is about the context. We're looking for meaning, interpretation, those type of things. You want to observe something and you want to kind of figure out what am I looking at here. So that comes down to the role of the researcher. The role of the researcher, you're very unobtrusive. You don't intervene that much. You're basically just trying to watch and see what's going on, meaning that it takes place in sort of a normal naturalistic environment. And as I mentioned last time, it's time and space specific. Normally, you're not generalizing, because if you're going to do qualitative research, you're usually doing it in one place over a certain time frame, and you can't say that you could replicate that. You go to another city, you may not get the same thing. So you can only talk about what you did at that one place and at that one time. So to a large degree, it's information is narrative, meaning that you know with qualitative you're telling a story. I talked about that before. The information you get is packaged in a way where you're narrating. You're the one who's telling the listener or the person who's reading what they're looking at. Now with the research design, which we could look at qualitative methodology, you have to have a strong rationale of why you're doing it. Because it's not really as normal to do the qualitative methodology. Most people are very familiar with quantitative. But if you really feel, for example, in my case, when I did my research at Flint, I started off doing a quantitative study. The advisor I had who wanted me to what I was going to ask was the question, going back to the concept of the question. I wanted to know about environmental justice. You know, I was looking at this concept, it was a new concept, and it dealt with communities that were disproportionately exposed to hazards and so forth. And I said, well, I want to find out if they know about this and whether it's used as a mobilizing tool or whatever. And so since this guy was a quantitative professor, he was saying, well, you got to do a survey, and so I had to get maybe 3,000 people to fill out this questionnaire, and then I was trying to figure out, well, should I do it by mail? If I do it by mail, that means I got to have all the envelopes and all this postage, and I got to have all these addresses to send it out. I said, well, maybe I could do it by phone. So I thought about, well, phone, it's just me. I got to call all these people myself, if they're not home, they hang up the phone, wrong numbers. And I was going crazy because I'm trying to figure out, now that I've submitted my proposal and it's approved, I got to actually do the research I said I was going to do. And I realized it was monumental, right? So I had encountered this other professor who said, well, have you ever heard of qualitative methods? And I'm like, no, what's that? He says, well, that's when you ask a few people, questions, deep interviews and so forth. And, you should be talking to the activists. And I was like, yeah. He said, this is he called it a purposeful sample. He said, if you only want to know about environmental justice if it's used as a strategy or tactic, why are you asking 3,000 strange people random across a city who are most of them are going to respond, I have no idea what you're talking about. I have no idea what you're talking about. I have no idea what you're talking about. All that wasted time and effort. So I dropped the other professor and picked this guy up, and I did a purposeful sample of about 30 activists where I asked them specific questions about the siting of the waste facility, what were they doing to mobilize and organize, and so forth. And actually I got a better dissertation because it was a qualitative dissertation, because the question I was supposed to be asking were supposed to be only to 30 people, not 3,000 people. And so that's why I say here with the qualitative methodology, you have to have a strong rationale for trying to use it, and a deep commitment to time and resources. Like I said, here you may not have that time. I mean, I was working on a dissertation, so I had years to do this stuff. But here you may have to cut it down to be very short and not really too in-depth. Issue complexity, a lot of times you want to use this when you have a lot of complexity in the issue and you want to look at it from different ways, and so you have that flexibility. You may have a lot of variables, but you may have a few cases. Like I said, I had a lot of variables, but I only had 30 cases of people that I talked with. So it's a very different paradigm as far as perception, language, and goals. Okay, I got to move this along. So let's I'm going to speed this up now. So I'm going to do a comparison. The quantitative seeks facts and causes. It's very subjective about the states of individuals. It can be obtrusive in like I said, controlling the measurements. It's looking at research from an outsider perspective, and they're looking for outcomes. Where the qualitative, whoops, sorry, I didn't want to do that. Let's go back. Qualitative concern with the understanding of the human behavior from the actor's own frame of reference. It's naturalistic. We're looking at it from more of an insider perspective, and it's more about the process rather than the outcome. With quantitative data, a lot of times it's ungrounded. It's about verifying, and like I said, talked earlier about reduction and inferring. It's about that hard, repeatable type of data. You know, we look at something in particular, and you're really assuming that reality is stable. Like I said before, same questionnaire to the same people, you're going to get the same information. Where the qualitative is much more grounded in the idea of exploring and expanding and describing. You get these sort of, you're validating what people are feeling. When they tell you something, that's validation to them. It's rich, it's real, it's deep, it's about holistically looking at what you're doing and assuming that reality is dynamic, that it's always changing, it's not static. All right. Now, like I said before, the different paradigms, when I did my research, I changed the language. When I did qualitative, I didn't talk about research, I talked more about inquiry. I didn't talk about my people, respondents, as subjects, I called them participants. Rather than collecting data, I was constructing data, I was kind of building data. I was evaluating rather than analyzing. And the thing I think that was the most cute was the idea of, instead of having findings, I had tellings. You know, so I was saying this is what people were telling me. So they can be complementary. Basically, it's a multi-purpose approach. When you're doing this stuff, you're monitoring by using two methods. You're looking at the impact assessment and the causal explanations. Now, what's going to be real interesting here is that this is how one could look at using the methods together, where you can have a sort of a sequential process where you can maybe start off with a pilot study, and from that pilot study, you can, which is qualitative, you can end up doing a survey, which is quantitative. And so the pilot study of asking people general questions can help you move towards having specific questions. The other thing that you can do is have a survey, because remember we talked about surveys, they're really set the kind of questions that you can ask. They're not necessarily open-ended. So you may ask these questions, you know, using a Likert scale or true, you know, multiple choice, true and false or whatever. And from that data, you might say, well, this is limited, I need to know more. So then you start interviews where they're more open-ended. So you're going beyond the survey to get more information. So part of this process is what we call triangulation. This is when you use multiple methods for basic types of triangulation. Triangulating by using data, by using variety of different data sources. Triangulation by investigators, by using different evaluators to look at the same thing. Triangulation through theory, where you use multiple perspectives to interpret a single set of data. So looking at it from different perspectives, different theories, how one theory looks at the same thing. And then methodological is what I did in my work, was doing multi-methods of studying the same problem by using interviews and observations. And you know, I did focus groups as well as in-depth interviews, library research and things like that. Now the obstacle to using both methods is that obviously it's expensive, you know, because you got to pay for, like I said, all the paper and the time and equipment and things like that. It's time consuming, obviously, using more than one method. And also a lack of training. Most people either know quantitative really well or qualitative. There are very few people who are trained equally well in both methods. And it's also part of this dialectic form of debate, where some people will think that the best way to do it is quantitative. No, the best way is qualitative. You know, you're always going to have some people who are going to be the best way to do it is one or the other. So you know, in conclusion, I think this is important when we think about this as a significance of community, university, and interaction, or what one of my colleagues once called a notion of communiversities. And I think this is kind of the point I'm trying to make about doing research and the internships we do, is that we are moving into looking at community life experiences. Wherever we go in our internship, you're sort of part of another community. You're leaving the university and you're going into another community. And out of that, you can come with a very effective research and policy. And then, of course, you're coming with academic knowledge and theories and concepts and principles. And basically, it's combining these two perspectives is what gives you the rich information that you're going to have and the skills that you can take into the workforce in the future. So these are the references. They're, I'm not going to spend much time on them, but you know, this one here is the book that I use most of the presentation came out of Research Methods, a Process of Inquiry by Garazino and Rulin. You can also get some good information from this one. We're evaluating information, a guide to use of social science research. Oppenheim, I didn't really use much of this in my presentation, but Oppenheim wrote this book on questionnaire design, interviewing, and attitude measurements, which can, if you decide you want to see how do you do these things, that's a good instructional book. This one by Patton, it was in the first presentation. I brought it back again just to sort of talk about triangulation and the qualitative methods, and then how to conduct your own survey by Salan and Dillman.